Hi, in this video I'm going to solve two truss questions and using the cut approach. And as you can see, we have here truss with a lot of links, and it is asked to find the forces in three members including EF, EP and LK. As you can see here, we have a lot of members, and but we need to see how we want to cut this. If it is okay to find three members and cut through them and use the unknowns using that cut, you don't need to consider the whole structure, meaning that it may be seen as a very complex problem at the beginning because of a lot of members, but because of having a cut and finding only three unknowns using that could be a very simple problem. I would say that let's consider the unknowns here. One of them is here, the other one is here, the other one is here, meaning that we can do a cut like this through them and find three unknowns. But before that, we need to find the reactions, meaning that if I consider this guy here, the roller is adding another unknown and I cannot solve this, meaning that here I need to do a freeway diagram of the whole system and solve the problem after that. The other thing here is zero force members. As we can see, we can go through the problem and solve the unknowns by using this cut. Finding the zero force member could be useful if we cannot find such a cut, meaning that we can have four members or something like that. By the way, finding zero force member is a good step, but not necessarily in this problem. And we have lots of them in this problem, including this one, and after that this one, also this one, and this one, this one, this one, and also this one. These are all zero force members of this problem, but we don't care about them because we can do a cut through three links which are unknowns. Okay, then our first step here is free body diagram of the whole system, and by doing that I need to consider the whole system as this. What I would have is a force for A in X direction and in Y direction, and also I have a force of I in Y direction. These are the reaction forces, and we have some external forces applied on the system. And by considering that, we can find the reaction forces. The best way to find the reaction forces is sigma m around A, and we need to consider all these forces, one here and one in the middle and two here and here. This is the free body diagram of the system. By taking sigma m around A equal to 0, let's put the AX and AY here as well. That would be helpful. IY. And by taking sigma m around A and considering counterclockwise equal to 0, I would solve IY. Okay, let's get started. I would have minus 2 times its arm. As it said here, we have 8 members over here, and each one of them is 2 meters, meaning that this is 2, the other one is 2, then this should be 4, and I have minus 5 times 8, and I have minus 3 times 10. I have minus 2 times 12 plus I in direction of Y times 16 equal to 0. Okay, by doing this we can find iy as the unknown, and let's get this done by doing the simplification. That would be minus 8 minus 40 minus 30 minus 24 plus 16 iy equal to 0, and what I get here is 4878 minus 24, and that would be 102 negative, and if I erase these ones and put the result instead of that, that would be minus 102, and so let me double check this. Yeah, minus 102. I need to erase everything over here. And by doing this, you can find a y equal to 102 or 16. And this is what we get for iy actually. And by having iy, we can do a free body diagram of this part, meaning that we can get this part separated from the left part and put iy over there and solve the problem for that. Okay, let's get started on doing that. I just erase these things and just put 102 over 16 instead of iy. I have a free body diagram over here that would be like this, and what I have is 102 over 16. Instead of these links, I want to put there. Actually, let me erase this and use the red color for this way. I have these links, and the structure is like this, here and here. And as I said, we don't care about the zero force numbers here because we have 3 unknowns and it's okay to go through that. Let me put the correct directions. Actually, what I would have is I have 2 over here, kn. I have 3 over here, and I have 3 forces over here, which are in these orientations. Here it's not easy to find the correct directions of the forces. I just put some arbitrary directions for them. For example, this one, and this one maybe. I put the names for them. For example, I put this one force EF. I put another force EP, and I put another force FLK. As you can see right now, we have 3 equations and we can solve the problem. And if we want to write down them, sigma of x equal to 0, sigma of y equal to 0, and sigma m around any point equal to 0. As discussed in the previous video, the art is finding the order of these ones and the point that we are taking the moment around. I would say I start with sigma m around point E. And why is that? Because if we do that, we get rid of two of forces, because these two forces are not making any moment around this point. They don't have any arm. And the only unknown here is this guy. By solving this, we found this. After that, which one of these equations do you choose? I would say sigma of y is a better one. Why is that? Because this is the only unknown which is making moment, which has some projections in y direction. These two are not contributing in y direction. We can solve this and find this. And after that, sigma of x. We have done a similar thing in the previous video. You can double check that video to see how we solve these ones. That's very easy, straightforward. And the only thing here is finding the reaction forces and doing the cut. Okay, I just skipped this step, and you can double check the previous video to see how we can find those things. After finding these ones, all the unknowns are found, because we are looking for only these three unknowns. And yeah, that's it for this question. I'm just jumping to the next one, which is here. And okay, let's see what we are looking for. Actually, these are the members that we are looking for, the internal forces. One of them is ED, EH, and GH. And as we can see, we have a roller over here and a pin over here, meaning that we would have two unknowns over here. One of them AX, the other one is AY. And for the roller, we have just one force, which is FY. And right now, here you can see that if we do a cut over here, we can have only three unknowns and we can solve the problem. But we need to do the Freeway Diagram of the whole and solve the equations for the whole system to find these three unknowns, because we need this unknown over there. And as we said, Freeway Diagram of the whole system has three equations, and we usually don't care about sigma of x and sigma of y, and we usually don't use them, and the only equation we usually use is sigma m around any point. But here we select a, because by selecting a we get rid of these two unknowns and we can find fy. And by doing that, sigma m around a equal to 0 can be solved. Okay, I consider the counterclockwise direction as a positive direction. For understanding which one is making the positive moment or negative moment, you put your finger here and assume that each one of these guys is making a motion around this way. If that motion is counterclockwise, that would be positive. If it is clockwise, that would be negative. If I put my finger here, this guy is rotating around this way. It's like rotation, right? Meaning that that would be positive. Then I put 40 times its arm, which is 1.5 meter here. That's the positive moment which this force is making. Okay, the same for 30. I have 30 times 3, which is this arm. This guy is not making any moment, it goes through that point, and that's a good thing for us. This guy is making counterclockwise as well. Then I would have plus 40 times 2, which is the arm. Here, this is the arm, and I have negative Fy because we consider Fy upward, and this making a clockwise motion, and that would be Fy times the arm, which is 4. And by solving this, we can find Fy. Let's get this done together. That would be 60 plus 90 plus 80 equal to 4 times Fy, meaning that 4 Fy is equal to 230 and we can solve this. Fy equal to 230 over 4, which has a value for itself. Okay, by finding Fy, we need to do the cut, and if I cut over here and do the freeway diagram of the left part, what I would have is something like this. I have this guy, and I have these 3 lengths. I put Fy over there because I got a positive value. I put this direction, actually upward direction, and I would have 40 over here. And I put my unknowns over there, meaning that I would have 3 unknowns over here, here, and here. And for finding the correct direction, it is not necessary, but it is possible. If you put your finger here, these 3 forces are going through that, and the only forces which are making moment around this is this one and this one. This one is rotating this way, meaning that this should be this way. Okay, this is this, and you can do the same thing for other forces. And I would say that this guy may be this way, and by having that this guy may be this way. These two are just assumptions, but this one is definitely this way, because we need to keep this guy not rotating and it's in equilibrium, steady equilibrium conditions. Okay, right now we have the same problem as the previous one, just by naming these ones and just double checking the previous video. You know how to do this. I just review the roadmap of that solution, and you can double check that video for realizing how to do this. Actually, we need to use the sigma of x equal to 0, y sigma of y equal to 0, and sigma m around any point equal to 0. The point that we can select here is E, because 2 of them are going through that. And by doing this, if we do this, that would be it gives you FGH, and then you do sigma of y. The only unknown in that direction is FEH, and then you do sigma of x, and then this is the first one, this is the second one, and this is the third one we do, and you can find FED. As you can see, the problem like this is easy because we can find the line which goes through 3 links, and the other thing is that the freeway diagram of the whole system is solvable because we have two joints, and one of them is the roller, meaning that in total we have 3 unknowns. This is the point of this problem and the previous one, and if you double check the previous video, you can deal with all kind of these problems. Thank you so much.